All right, here's part 2 of the alternate assessment transformation packet. We're going to look at the last 2 pages, and I'm going to do a couple of them from each of the, I'm going to do like 1 or 2 from each page. You follow the same steps as I do, you should be able to do the rest. Right? Make sure you copy them down, because that, once I do, will still be graded. All right, I'm going to do number 1. All right, so we are going to looking at the graph of quadratic, and we're going to come up with an equation: vertex, domain, and range. All right, so I like to do these 3 first, and then do the equation last. All right, so the range, we want to look at the highest or the lowest point. So here's the highest point, all right, which is at 7. Okay, so I'll put 7. And notice the graph goes down, so we know that y is less than or equal to 7. So here, the lowest point is here. It's not the highest point, it's the lowest point. The rest of it goes up, so therefore it will be y is greater than or equal to whatever the value is. Right? Now, the domain, as I said before, for all of these will be all real numbers. The vertex, remember, it's the max or the min. So the coordinate point of this is, well, it's on the x-axis would be 0 and 9. So there is your vertex. Now the standard form would be y equals a x minus h quantity squared plus k. All right, first of all, look at A. A tells me, is it positive or negative? Well, it opens down, so I know it has to be negative. X, did this graph move left or right? Remember, the parent function, the vertex starts at the origin. Okay? Now, it went straight up. It didn't go left, it didn't go right, or it didn't go down. So H, there's no H, so you just leave it. Okay. Now K, it went up, what? 1, 2, 4, 6, 8, 9. It went up 9. It went up, so therefore it's positive 9. So y is equal to, so we can rewrite this as y is equal to negative x squared plus 9. Now, is it skinny? Is it skinny compared to the parent, or is it wider? We're not too concerned about that right now. I just basically want to know, is A positive or negative? Do I have an H value, and do I have a K value? In other words, did it go left, right, up, or down? So you should be able to do the rest. All right, last page. Now I'm giving you the functions. If you notice, they're all in vertex form. So you're going to graph all these using vertex form. So you can always refer back to the videos. Graphing, I think 4.2, graphing functions using the intercept form, vertex form, and standard form. For these, you want the vertex form. All right, so my vertex here is -2, -3. Remember, it's opposite of what's that stays the same. So let's see here, -2, -3. There's my vertex. All right, so this means right here is my axis of symmetry. So all I have to do now is find my y-intercept. So to do that, you make x 0. All right, so 0 plus 2 is 2. 2 squared is 4. 4 minus 3 is 1. So at 0, 1, that's where it crosses the y-axis. So the distance from here to the axis of symmetry is 1, 2. So that means on the other side, I'm going to go 1, 2. And there's another point. All right. All you need is 3 points. You don't need 5 or whatever. You need the vertex and then 2 other points. All right, let's try one more. Let's try number 5. Well, not try, let's do number 5, excuse me. Okay, vertex, you notice there's only x with the square. There's no h inside there, like all the other ones. So that means it's 0. And my a or my k is -5. So 0, -5, there's my vertex. Now you notice my vertex is the same as the y-intercept. Because here they were different, so I was able to use both of those in the graphic. Here, I don't have that luxury, so that means I have to pick another value for x. Alright, so I'm going to pick 1. I'm going to plug 1 for x, so 1 squared is 1, times 3 is 3, 3 minus 5 is -2. So then I'm going to go to -1, -2. And remember, this is my axis of symmetry, so the distance from here to the axis is 1, so therefore I go distance of 1 on the other side. And there's my function. So you should be able to graph the other 4. Alright. Now just be careful with the negatives, because that tells you how they open. Alright, so when you graph, it should open according to what A is, negative or positive. See, A was positive here, so it should open up. Yes. A was positive here. Does it open up? Yes.